What if I told you that in 1962, the United States accidentally nuked space? And I don't mean some metaphorical, symbolic space war. No, this was a full blown megaton sized nuclear bomb, detonated 250 miles above Earth, not as a mistake, on purpose. The mission was called Project Starfish Prime, and the aftermath was far weirder and more dangerous than anyone expected. When that bomb exploded in the night sky, it knocked out satellites, lit up the heavens, and accidentally created a radioactive belt around the Earth. Sounds like science fiction, right? Nope, just Cold War logic and a touch of cosmic chaos. But here's the real question: what if it happened again? To understand why anyone would nuke space, you need to understand the paranoia of the Cold War. In the early 1960s, America and the Soviet Union weren't just racing to the moon, they were stockpiling enough nuclear weapons to destroy the Earth several times over. And as rockets improved, so did the possibilities for nuclear warfare. It wasn't just about hitting Moscow or New York anymore. What if you could detonate a bomb in space? What would happen? Of course, the US government didn't want to ask, what if? They wanted to see. So they devised a test. Launch a W-49 thermonuclear warhead, strap it to a Thor missile, and detonate it at 250 miles altitude right in the lower reaches of the Van Allen radiation belts. And in July 1962, under a classified program codenamed Operation Fishbowl, they did exactly that. Only, they didn't fully understand what they were about to unleash. On July 9, 1962, residents of Hawaii looked up into the night sky and saw something utterly unexplainable. A bright flash brighter than the sun, followed by eerie auroras and glowing clouds stretching across the Pacific. It was like the northern lights had overdosed on LSD. The bomb, Starfish Prime, had exploded with the force of 1.4 megatons. For comparison, that's about 100 times the power of the bomb dropped on Hiroshima. And the detonation did more than just paint the sky. The resulting electromagnetic pulse, or EMP, was so powerful that it knocked out streetlights, triggered burglar alarms, and shorted out electrical systems in Hawaii, 900 miles away. But wait, it gets weirder. The blast also created something no one predicted: a massive artificial radiation belt surrounding the Earth. So, what exactly does a man-made radiation belt do? And why is it terrifying? The Earth already has natural radiation belts called the Van Allen belts, which trap charged particles from the sun using the Earth's magnetic field. They act like invisible shields, protecting us from solar and cosmic radiation. But when Starfish Prime exploded, it injected an enormous amount of high-energy electrons into the magnetosphere. And those particles didn't just vanish, they stuck around for months. What the US had unknowingly done was poison part of near-Earth space with radiation strong enough to fry satellites. And it did. The first casualty? A satellite that wasn't even American? Within days of the explosion, Telstar, the world's first active communication satellite, began to malfunction. Launched just a day after Starfish Prime, it was never meant to endure intense radiation. Its delicate circuits were slowly cooked by electrons that should not have been there. But Telstar wasn't alone. Other satellites, Ariel 1, TAR-AAC, Transit 4B, all fell victim to the storm of energetic particles now swarming Earth's magnetosphere. In total, at least 8 satellites were crippled or destroyed by the artificial radiation belt. Let's pause for a moment. This wasn't wartime. These satellites weren't spying or dropping bombs. They were early pieces of a growing space infrastructure casualties in a test no one really understood. But maybe the most disturbing part wasn't what Starfish Prime destroyed, it was how long its effects lasted. You might think, okay, a nuke exploded in space, surely the radiation just dissipated, right? Wrong. The particles trapped in Earth's magnetic field lingered for months. Some scientists estimated it took 5 years for the artificial radiation belt to finally decay and dissipate. During that time, launching anything into low Earth orbit became a gamble. Imagine trying to build a global satellite network while dodging an invisible death cloud circling the planet. It was a costly mistake, but not an easily fixable one. You can sweep up nuclear debris on Earth, but in space, there's no cleanup crew. And here's the million-dollar question. What if we did it again today? First, let's talk about capabilities. Technically, yes, we still have the ability to launch a nuke into space. Several countries do. The technology hasn't gone away, but the consequences would be far worse now than in 1962. Why? Because today, we rely on space for everything. Weather forecasting, GPS navigation, global banking, internet communication, military defense. airline traffic, stock markets. We live in a digital ecosystem that is utterly dependent on satellites. In 1962, losing a few satellites was tragic but manageable. In 2025, it would be catastrophic. But here's the really uncomfortable truth. Nuclear space detonation isn't just a Cold War relic, it's still part of some modern military doctrines. While no one's admitting they plan to nuke space again, the idea of high-altitude EMP weapons, detonated miles above the Earth to knock out electronics, hasn't gone away. Some military strategists have floated it as a non-lethal first strike option. No civilian deaths, just no power, no satellites, no GPS, no communication, just darkness. Imagine a nuclear detonation 300 miles above the US. It wouldn't burn cities, it would black out the entire electrical grid, destroy satellites, and plunge the nation into chaos. That's the power of a high-altitude EMP weapon. And we've already tested it. In 1962, are there treaties in place to stop this from happening again? And would they even matter? After the 1960s, the global community realized that nuking space maybe wasn't the best idea. So in 1967, the Outer Space Treaty was signed, prohibiting the placement of nuclear weapons in orbit or the testing of weapons of mass destruction in space. That's good news, right? Well, sort of. Because like many international treaties, enforcement is murky. What if a nation claims the weapon was for defense? What if it's launched covertly? What if a rogue state or a well-funded terrorist group gets their hands on one? And even if we obey treaties, space is getting crowded. There are over 8,000 active satellites orbiting Earth right now. Companies like SpaceX are launching thousands more every year. Our low Earth orbit is turning into a traffic jam. It's not just a potential war zone, it's an overcrowded one. So if a single bomb created a belt of radiation that lasted years in 1962, what would happen if someone dropped one today? Let's say, for the sake of argument, a rogue actor detonates a nuclear device 300 miles above the Earth. First, there's the EMP. Power grids in an entire hemisphere could go down. Planes would be grounded, communication lost, satellites, many would be permanently disabled. Then comes the radiation belt. Unlike the natural Van Allen belts, this one wouldn't be predictable. It would damage everything that passes through it. Satellites could be fried on launch, manned space missions, like to the ISS, could become lethal. And unlike 1962, we need space to function. From crop monitoring to defense systems, we've built a civilization that cannot afford to lose orbit. One nuclear detonation could set us back decades. Starfish Prime wasn't a failure. It worked exactly as intended. A successful test of a high-altitude nuclear explosion. But it was also a wake-up call. It taught us that space is not an empty void. It's a living, interconnected system. What we do up there doesn't stay up there. It comes back to bite us in very real, very dangerous ways. We learned for a moment that science fiction could become science fact. And now, as we race toward moon bases, Mars colonies, and mega constellations of satellites, it's worth asking, have we truly understood the fragility of the space environment? Or are we too busy fighting for dominance to notice we're standing on a digital house of cards? Because one nuke in space changed everything in 1962. What happens if someone tries it again? And more importantly, would we survive the second starfish? Let us know what you think in the comments.